All right, this is a review of section 6.4, using inverse functions. So, pause the video and see how you do here. So it says to find the inverse of the function and then verify that your result and the original functions are inverses. So first I'm going to find the inverse. So that means switch x and y and resolve for y. So I'm going to subtract 5 and divide everything by a -3. And then that's going to turn to positive, right? So there's my inverse, -1/3 x plus 5/3. And then it said to verify that they are inverses of each other. So to verify, remember, you know they're inverses. To verify means you have to show f of g of x. Actually, let me erase this. This is my inverse, so I'm going to write f to the -1x, right? That means inverse. So you have to verify by doing f of f to the negative. So the composition of the inverse and the composition of the inverse and the original function. And both of those should equal x to verify your inverse. So I'm going to start with f of the inverse of x. And that means I'm going to take -3x plus 5, but I'm going to replace the x with -1/3 x plus 5/3. And I'm going to distribute that through, so it's going to be a positive 3x over 3 plus 15/3 plus 5. Well, I know 3/3 is 1x, 15/3 is, I'm sorry, that's a -5. And sure enough, that equals x. All right, then to verify my other inverse, I'm going to do f of inverse of x. So that means I start with my inverse, but I'm going to replace my x's with the original function, -3x plus 5. Okay, so this I'm going to rewrite as -3x over -3 plus 5 over -3. So I just wrote both of those over -3. That cancels out to x, and these cancel out, so I didn't need that, and so it equals x. So now remember, when you verify, it means to show that both of these compositions equal x. Okay, let's find the inverse of a few of these. So switch x and y, subtract 1, divide everything by 2, and then I'm going to fourth root. So I'm going to fourth root that entire quantity. And remember, when you fourth root, if I can squeeze it in there, it's plus or minus because it's an even root. So there's your inverse. Part B, you switch x and y. I'm going to multiply both sides by 32 to get rid of the 132. And then I'm going to fifth root both sides. And I don't need plus or minus because it's an even root. But the fifth root of 32, oops, I forgot fifth root there, sorry. The fifth root of 32 is 2. And that's the inverse. All right, the last one says to determine whether the inverse of f of x is a function and then find the inverse. So first of all, you will also be asked to graph these. So I'm just going to note that this is a cubic function and it's positive, so I kind of know, what a cubic function looks like, something like this. Depending on how curvy the middle is, it may or may not be its inverse may or may not be a function. So I'm going to test enough points that I can have an idea of what this looks like. So for example, let's start with, like maybe -2, -1, 0, 1, 2. Those are always kind of easy to test. I'm going to just talk through these in my head. So -2 cubed is -8. A fourth of that is -2 plus 1 is 1. -1 cubed is -1 times the fourth is a -4th, and plus 3 is nope, not negative. Now I lost my train of thought. So let's see, that's going to be negative 1/4 plus 3, which will be 2 3/4. 0 is pretty easy. That's going to be 0 plus 3, which is 3. 1 times a fourth is a fourth, plus 3 is 3 1/4. And 2 cubed is 8. A fourth of that is 2, plus 3 is 5. So let me kind of blow up my graph here. So negative 2, 1 is my first point. Then I have negative 1 and 2 3/4. Roughly right there. Then I have 0, 3. And then I have 1 and 3 1/4. And then I have a 2 and a 5. So it kind of almost looks like it's going to be a straight line, but I still think that I'm okay with this because I know it's really going to do this, so it's probably just not much of a loop-de-loop there in the middle. So I'm going to just be okay with the fact that it doesn't have a whole lot of curve in the middle. So is the inverse going to be a function? Well, if I do a horizontal line test, I'll always just go through one point. So that means the inverse is a function. Now, if you had more curvature, like this one, I'm going through 2 points, then my inverse won't be a function. Now, what if it asks you to graph the inverse? And I know the directions don't say this, but you're going to have to do it on the test, so I'm just going to add that in here. If I graph the inverse, that means I'm going to switch x and y. So it's going to be 1, 2 3/4, 3, 3 1/4, and 5, and then negative 2, negative 1, 0, 1, 2. So if that's a 1. If I plot those points, I'm going to have 1, negative 2, 2, negative 1, 3, 0. Oh, I'm horribly off, sorry. 3 1/4 and 1. So 3 1/4 and 1. And then 1, 2, 3, 4, 5, 2. And then I know that that is going to kind of do this. And remember that your original function and your inverse function always reflect over the line y equals x. So you can kind of see that they do reflect. It also says to find the inverse, so just real quickly, if I switch x and y, and then I'm going to slide this up, so I would subtract 3, and then I'm going to multiply by 4, and be careful, it's 4 times that quantity, and then I'm going to cube root it. So it's going to be the cube root of 4x minus 12 if I distribute that 4 through, and I don't need a plus or minus because it's cube root.